It's a shame we can't be with you today, but we've been doing the best we can to put together a workshop here at Bangor University. Today's workshop will look at how chemistry has affected our healthcare. Chemistry has played an important role in healthcare, and this has meant we can live long and healthy lives, much longer than we would have done 100 years ago. So first of all, can you think of how chemistry is used in healthcare? I'm sure you've come up with lots of good ideas, but here are some more examples. Chemistry has allowed us to make plastic, and it is used a lot in healthcare. Here you can see a baby inside a plastic case. Some babies are born too early and need lots of looking after. The plastic cases can help them stay safe and warm. Some people struggle to take medicines as tablets. Plastic patches can be used for some medicines instead. This is then absorbed through the skin. When we think about chemistry, it can make us think about chemicals. Different chemicals are used to make medicines, which we can then take to help us fight different diseases. We can also use chemicals to deactivate viruses, which can then be made into vaccines. Vaccines are an effective way of wiping out diseases. There are also chemical tests that can be used by people with diabetes to let them test how much sugar is in their blood. And the future holds many more new and exciting breakthroughs which could help solve lots of different problems. Plastic blood could be used as a substitute for real blood in emergency situations. Artificial skin that can sense temperature and touch could be used to cover artificial limbs. Nanotechnology, which is the term for using extremely small things, can be used to deliver medicines to very specific areas in the body. For example, they could be used to target cancer cells. Let's have a look where we can find chemistry happening in North Wales. There are laboratories and hospitals which look and test samples from patients. Siemens in Llanberis makes products which test for diseases and allergens. And Bangor University carries out research on drug delivery using nanoparticles, on coronavirus by looking at sewage, as well as the uses of natural materials in healthcare, which is something we're going to be looking at today. The two topics that we're going to be looking at today are wound dressings and drug delivery. First of all, we'll look at drug delivery. To recognise how chemistry has impacted our healthcare, it is important to look at the history, so what we used to do before we knew about the chemistry. Healthcare's history is basically a story about how it got better. Ancient remedies offered a hit and miss range of treatments. Let's see what these guys thought. Drinking wee from a sandal cures all ills. Drill a hole in your head. That will get rid of your headache. Shave a live hen's bottom and strap it to your spots to cure the plague. Yikes, no thanks. These ideas didn't work, so we don't use them today. Therefore, we've learned from our previous mistakes. Let's look at the history of drug delivery a bit closer to modern times. In 1928, a scientist called Alexander Fleming accidentally discovered that mold juice, which we now know as penicillin, is capable of killing bacteria. After returning from a holiday, Fleming noticed some old petri dishes had been exposed to mold spores in the air, and the bacteria he had grown were being killed. This may explain why the ancient Egyptians put mouldy bread onto their infected wounds. So through time, everything that has worked is what we still use today, and we now know that we can safely receive medications through tablets, patches and injections. Now we will look at wound care. This is what our practical will be focusing on today. Early ideas about plasters used a mix of mud, oil and plants to cover up their cuts. It was thought that this would protect the cut and absorb the pus. We now know that this is not a very good idea. Another early idea about wound care used maggots to eat rotting flesh. During the war, surgeons noticed that soldiers whose wounds became infected with maggots were less likely to die. Another early idea about wound care used amputations. This became popular during the war after a new bullet came into use which caused limbs to shatter. At the time, the only way to treat a shattered limb was to remove it. The first wound treatments were described nearly 5,000 years ago. Since then, different ideas have been passed on through generations. Knowing what we do now, it's possible to treat wounds very effectively. There are many different wound dressings, over 3,000 different ones, and advancements in surgery mean we can mend broken bones instead of removing them. have organ transplants, or even brain surgery. Now we're going to look at some things which are being researched which might change the future of healthcare. Scientists are looking at using natural materials instead of man-made ones. Why might using natural materials in healthcare be a good thing? Some other examples are that they are non-toxic, abundant, which means there is lots of them, and they can be cheaper than other materials. The natural material we're going to be looking at today is seaweed. Brown seaweed can be used to make something called alginate. It has some unusual properties, as we will find out, but it ticks all the boxes. It is cheap, abundant and biocompatible. Let's have a look at what alginate looks like. In this demonstration, I'll be showing you how alginate is formed. So that you can see it clearly, a fluorescent dye has been added to the alginate so it glows in the dark when we put it under a UV torch. The alginate starts out as a liquid, but it can be made into a gel. When it's in a gel form, it has many uses, as you'll find out later in the video. For the alginate to form into a gel, a chemical reaction needs to happen. This reaction happens when the alginate is added to calcium chloride. First, we will make the calcium chloride solution by dissolving the calcium chloride into the beaker of water using the magnetic stirring plate. When the calcium chloride has dissolved, we can add liquid alginate into the calcium chloride using a pipette. If you look closely, you can see that the alginate forms gel beads when it comes into contact with the calcium chloride. When I turn the lights off, you can see the alginate beads that have been formed clearer. It might surprise you to know that this product is already being used in some things you might be familiar with by replacing some of the plastic components. It is used inside nappies. It can be used to hold water, to thicken food, make dental impressions, and replace the small beads found in beauty products. It can also be used as a wound dressing. Alginate comes from the sugars found in seaweed. Seaweed is collected, then dried. It's then processed to be made into alginate. When these sugars react with the calcium chloride, a sugar polymer is formed. Polymers are made by chemical reactions that cause lots of small molecules to join together to make long molecules. In today's practical, I'm going to be showing you how to make a simple version of a wound dressing using alginate. There are two different types of alginate, and we're going to be making both types so we can compare the differences between them. Firstly, I will make alginate type G. If we look to the structure of alginate G, we will see that the sugars are arranged as a zigzag. The method is the same as you saw in demonstration. We're using calcium chloride dissolved in water, as well as liquid alginate. Firstly, I will put 250 ml of calcium chloride into a beaker. Using a syringe, I will squirt the alginate into the calcium chloride. This time you will see that gel worms will appear. We will now leave it for 2 minutes. After 2 minutes, we can remove the alginate from the calcium chloride. As you can see, the calcium chloride has reacted with the alginate G sugars to stick entire chains of alginate together. When the chains stick together, the alginate goes from a gloopy liquid to a more solid, squidgy gel. I will keep this to one side to compare it to the other type. The other type of alginate is called alginate M. If we looked at the structure of alginate M, we would see that the sugars are arranged in a straight line. Again, I will use the same method. Placing the alginate M into the calcium chloride solution using a syringe. Again, we will leave it for 2 minutes. After 2 minutes, the chemical reaction will have caused the liquid to form into a gel. Here we can see the structure of alginate M after it has reacted with the calcium chloride solution. Now we have the two different types of alginate, we can look more closely to compare them. They look very similar, but if I pick it up and squish it, you might be able to see some slight differences. The alginate G feels harder and stronger, but it is more brittle, so it breaks when I bend it. The alginate M is squishier and more flexible, but it isn't very strong. This is because the alginate that is mostly G is much stronger than the alginate that is mostly M, because the chains are stuck together in more places. This stops the chains from bending, which means that the G alginate is less flexible than the M alginate. If you do bend it, alginate G will snap. In nature, seaweed in fast-flowing water tends to contain more alginate M. This gives it flexibility so that it doesn't snap in the strong current. G alginate is found in seaweed in calmer waters and is therefore more rigid. Do you think you would want a wound dressing to be weak and flexible or strong and brittle? The dressings that are used are actually made using a mixture of both types, therefore it gives them the advantages of both, making them strong and flexible. I will do the experiment again using a mixture of both types. I'll leave this for 2 minutes to allow the reaction to happen. After 2 minutes, I can remove the alginate from the calcium chloride. When the alginate is a mixture of G and M, it is both strong and flexible, and this makes it useful as a wound dressing. Wound dressings made of alginate are used on foot ulcers, which can form on a person with a certain type of diabetes. Ulcers can be much more difficult to heal compared to other types of wounds. The advantages of alginate wound dressings are that they can pack into a wound site better than a traditional dressing because they don't get stuck to the wound. They can also transmit oxygen and moisture to the wound, which can help with the healing process. Another advantage is that the dressings don't need to be stuck onto the skin and are therefore easily removed. This foot represents a wound from a diabetic foot ulcer. We can pack it with the alginate and secure it in place with a bandage. This shows a simple version of an alginate wound dressing.